horrible it is. I was like 12 or 13 years old. My dad told me, don't ever hang out with those friends of yours, particularly when you go to the river. Don't go with them. So if you're gonna play soccer, you're gonna play volleyball, you're gonna ride your bicycle, whatever, you can do it right there in the park. Don't go to the river with them. Because there was a river and it was very deep. Many people have died there. Knowing that, you know, kids, you don't believe anything. You think that that's not gonna happen to you. There was this big rock and everybody was jumping from there. And you don't want to feel behind. Everybody was jumping. I said, why not me? I was a little skeptical. I knew how to swim. Because I always have swimming classes, and always in the pool, I know how to swim. I jumped from that big rock, but I never thought that was so deep. So I felt like I was going on my way, because I was a little scared. When I jumped, I didn't have enough air. So when I jumped and I went down and I couldn't come out fast, I felt like I was short of breath. And I drank some water and I thought that I was drowning. That was the worst experience that I had ever had. Then I was like, can you imagine? I was 12, I was like half of my size, I guess. So little, I was struggling to get up, and that was deep. When I'm gonna kind of find support? Oh my goodness, you can imagine when it's not time for you to go. Somehow I felt something right there, and it was a rock, but it was very slippery. You know, that very slippery. Oh my God, I was like, I tried to grasp on, and I kind of went, but I have a little time to breathe. Then finally, I got to hold on to the rock. Oh my God. And everybody there, they don't even notice what was happening to me. And of course I didn't tell them, because I felt embarrassed, right? But that was my first and last time that I actually disobeyed my dad. I said, oh, my dad was so right. So I went home, I didn't say anything, but I was scared. I think that for over a month, I didn't go out, hang out with my friends. I was upset with them. I never told them anything, but I was like hating all of them, because it was their fault. They took me over there. Anyways, but that's how you feel, like grasping for air, like that's it, you're gone. That's horrible. So once again, look at the rate. Less than 20. You already collapse. Not enough, because your normal is 60 to 100. Less than 60. If you have someone who has a heart rate 50, 52, 55, and this person is a young person, probably this person practices sports. That is normal. They can be into the bradycardia, but they are not bad. But if it's an elderly patient or a child, believe me, they are in a bad shape. But we are talking about 50 and above, not below 50. Below 50, anybody is in trouble. So be careful. So these are the agonal rhythms. Look at how they happen. P waves, none. Because now the heart is going like this. And then becomes alive. If there are no P waves, you cannot count the PR interval. There's no, doesn't exist. QRS, white and bizarre. T waves, opposite to QRS, so they would be invariant. So it's like seeing the premature ventricular contractions And that's it. Anything else you want to see? Here it is. See? Very white. Line, very white, because it's already spacing, becoming flat. Because the spacing is flat. This is another rhythm. It's called the idioventricular rhythm. Now, once again, because it's ventricular, see, in order for you to respond to the questions, is when they ask you, they give you the information in the question. They say idioventricular rhythm. It's ventricular data. So what are you going to be looking at? The ventricles. Check the ventricles. Mm-hmm. 20 to 40. That will be the rate. It's going to be regular. P waves, no P waves, because they're talking about just the ventricles. This is just the ventricles that are working. The SA no, it's not working. The atria is not working. Usually when we get a question in the exam, we put all these things together. No. If the question is talking about atria, think about P wave and the PR interval. That's it. If they're talking about the ventricles, we're going to be thinking and looking for an answer related to the QRST. That's it. Whether it's the contraction, QRST, whether it's the relaxation, the T. It can be regular P waves, no P waves, because we're talking about the ventricles only. This is idioventricular. So we're going to see again those QRS kind of very bizarre. Bizarre means goes very wide. Very weird, if you will. Remember, if we don't have P waves, we don't have PR intervals. Doesn't make sense. Here we have it. It looks a little bit like the agonal, right? But these ones are closer, so you still have many of them. 1, 1, 1, 1. The other one is 1, and the other very far away, and then disappear the other one and the flat line. But these can lead to that. Because if the heart is, see, it has 20 to 40 beats per minute. And if this is not addressed with medications, with treatment, the patient is left unattended, well, this 20 to 40 is going to become 10, it's going to become 0, and this is going to become wider and wider and wider, and next thing you know, you have a flat line. Now, if you see there, is this regular or irregular? Regular. It looks nice and clean. Now, we're not saying that the patient is normal. No. But normal and regular, there are very different things when we talk about EKGs.
When you say regular, you mean more like consecutive, right?
Yes, that makes sense, that the heart is beating at the same time. Here, the ventricles are beating at the same time. Here, from here to here. Look at this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. It's at the same pace. That is the rhythm. Irregular is that the heart beats faster, then slower, very fast, very slow. So you cannot kind of put yourself in a place that says, okay, which one do I pick? Remember the grades? You have 50, 70, 90, 100, 30, I cannot pick one of these numbers and give you as a grade. Then I have to get all of them together and get an average. What is the heart rate of this patient?
Regular is 6 bucks. 6, 7, this is 40.
Close.
What you said?
40. Because you count right here, right? 1, 2, 3, 4. And remember, it's between 20 to 40.
No.
So you see right there 40, but this is regular. Because
No.
it's regular, you're gonna use 300 over 80 is 43. Ventricular tachycardia. These are questions for exam. These are questions for exam. Remember, tachycardia means that the heart is beating very fast. But in this case, it's not the sinus tachycardia. Tachycardia goes 100 to 160, right? This is gonna go from 150 and below. Set rate more than 100 because it's tachycardia. But these are the ventricles that are going too fast. And because the ventricles are going too fast, remember, the atria, you're not going to see it. Now, the PR inner bone, if you don't see the big wave, well, you're not going to see the PR inner bone. The QRS are very wide. When we have problems with the ventricles tend to be wider than normal. The T wave is opposite. Here will be some of the causes. You will never be asked about what is the cause of this type of heart. So I don't want to go over that because I don't want to put too much stuff on your head. There's enough with this. I want you to recognize the pictures. This is this is a ventricular tachycardia. It looks like regular, right? It looks like uniform, like going the same. Remember, don't look on the upper part. These are the T's.
No.
This bottom one, from here to here, from here to here, so it looks like the same. Now, what's the heart rate for this?
More than 100. I mean, for sure.
How many? Oh, how many? What is the heart rate? When I say how many is, I said, do you count the QR?
214.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22, right? If you multiply it by 10, how much is it?
You divide it by
220. No, multiply it.
Okay. So I did it
220.
different. That's why. So which one is the one? Because what I did was I went to the one with.
If
I
you
had
use the
point,
blocks, pay attention to this, which one would you pick? I
the
would
one
pick
that's
this
on the
one.
line. I did the next one.
This
Not
one
that
is
one,
not on
next
the,
to
this
it,
one?
Yeah.
Okay, it's the same. So you have 5, 6, 7.
1,500 divided by 7.
Mhm.
Yeah, it's 214. So it would be
very close to 220.
Yeah.
But it's 200.
Yeah.
And the normal is 60 to 100. It's double. What is the P? Where is the P? Our inner ball. Nowhere to be found. Because it's ventricular tachycardia. So you're going to see only the part of the ventricles. The Q, R, this is the T. The S and the T is on top. So they don't even have the segment, ST segment. So pay attention to the picture because these pictures comes in your exam. And they're gonna ask you, okay, the following image is representing what heart condition? And you said, oh, because I know these are the ventricles. You said, oh, they were very together. Oh no, ventricular tachycardia. It is called torser de point. That's in French. That was the name of the cardiologist that discovered this condition. He said right here, this is a French term meaning twisting of the points. Polymorphic ventricular tachycardia. When you see poly, medical terminology means many, different shapes. Morphic means shapes. There are different shapes. So you're going to be seeing these ventricular contractions, the QRS, but in different sizes and forms. Is that understood? That's how you know immediately. Because think about this one first, the one that we just saw. It's like kind of the same image, right? Repeats nice and the same height, almost the same. The other one you're gonna see some tall, some little, some tall, some little, but it's the same morphology. It's just a change. Here it is. See? These are the same. See? QRS, QRS, QRS. Now it becomes small. QRS very big, small, small, very big. It looks like the decibels when you taping someone that looks like go like this, right? Exactly like that. That is the frequency and the decibels that you see there. This is called torser de point. And I like to mention this because if I don't mention it, you see these questions and I never heard of this person. But as soon as you see it, it doesn't matter if you don't get it right. But at least you know that, oh, I saw this name before. And you have an idea, probably as soon as you see the picture, the images, and said, oh, it's this one. Remember, if they are talking about ventricles, this, you have to look at the QRS. When they talk about atrial, think about the T wave. Because that's how we find the answers. You don't need to know it. It's just to relay the topics. Any question, guys? When we got to the last one, before to the last one. Very, very bad. This comes on the exams too. Remember, ventricular tachycardia, very common. Sometimes torser de point, that would be another one. Ventricular fibrillation, kind of 100%. Now, what is fibrillation? Fibrillation is when the heart is not beating, the heart is shaking. The heart goes like this, everywhere, shaking. It's not just contracting and relaxing. So for that reason, we're not gonna see any of the components of the EKG. Are we gonna see the P wave? No. Are we gonna see the QRS? No. The PRN? No, no, no. You're not gonna see anything. You see a bunch of little up and down lines, and that is it. It's very fast. Is the #1 cause of death in patients with heart conditions. Remember, tachycardia leads to myocardial infarction. Torcer de points leads to myocardial infarction. This ventricular fibrillation leads to myocardial infarction. But this is one of the most common. So sometimes the patient starts with ventricular tachycardia. But then the ventricular tachycardia becomes chaotic and it becomes this, ventricular fibrillation. This is the condition that we need to shock the patient. And that shocking is called defibrillation. Remember, when we learn CPR, we learn that we do the compressions, the breathing, but then at the end, we're gonna defibrillate. We're gonna use a defibrillator, which is we're gonna place the shocks on the patient and we're gonna shock the patient because we're gonna recharge these 3 batteries, the SA node, the AB node, and the Purkinje fibers. So the patient can regain their own electrical activity. Otherwise, patient is gonna be gone. See? No PR interval, no QRS, no TWX, nothing. So right there, myocardial infarction and many other things. So here it is. So pay attention to this image because it's going to be on your exam. When you see little things going up and down, but you don't see if this is a QR, is the P, is the QRS, or is the T, we don't know. We don't know. Can you tell me which one is the P? No. Correct. It's chaotic. Now, do not mix it up with the one we saw yesterday. Was the what was that? The atrial flutter. This is sticky. That was the saw teeth. Remember, it goes like this. Remember, I can see the QRS, the QRS, the QRS, but the T's, the B's, I don't know which one is it. Here, all of them are almost in the same level. So it's very chaotic. This is ventricular.
So with that one, you can identify which one is.
Yeah, here you know that this atria, because that's what it's called, atrial flutter, because there's something wrong right here. Now with the QRS. The QRS you see it clearly. The other ones are like a little, like the shark's teeth. You see all these little things like this, and then the QRS normal, all these little waves, deflections in between. But you don't know because there are more than one. It's not just the P, there's P, P. How do you know which one is that? Which one is the P? Because there are 3 or 4. You know, guys, that Monday is a holiday, right? No class. Did I tell you already?
I thought they would kill me. But
To be honest with you, you're totally right. I have one of my students. Remember, these classes you don't see many boys. I have in my EKG class one boy. It happens that coincidentally I have an EKG class and I needed someone. So I asked him, I said, listen, would you be willing to volunteer for one of my practicals that I have? And he said, and you know what? All of them are girls. That's what I need. Oh yeah. He said yeah. Very good looking. Oh my goodness. You know that?
when the lady saw him,
These girls were like, oh, I know. And everybody wants to repeat doing this and they were doing it wrong. Because they were like, oh, I could do it. So I just pretend, that I said, okay, I know. I'm trying to impress the boy. And he was like, kind of sleeping. I went because he got very, what's it called? Embarrassed. And then he was like, oh, no, I'm going to go sleep. If I sleep, that's okay. Said, oh, yeah, because your heart is going to be resting, it's sleeping better. And they were like doing EKG. I want to repeat. I want to do it again. I said, listen, repeat it, but just learn it right. Well, like I said before, for my students, I do whatever it takes because I really want you to learn the practicals. Listen, theory, you have your books, you can read it anytime, and this is not something that you're going to learn in the classroom. You're going to learn as you go. See, when I learned medicine, yes, of course, you have the basics. But do you think that I know how to diagnose? I don't know. When I went to the residency, it's like you, the first time that you're going to draw blood, you don't know where to start. And then you're thinking that your preceptor, these doctors that have been there for a long time, they're looking at you and they're asking you questions. Okay, you're going to do this. The patient has this. What physical exam you're going to do? What medication you're going to start this patient first? And what is this and what is that? Oh, my goodness. Good thing that, we learned that when we were in school, that, hey, it's the process of learning. And we're going to know and we're going to make mistakes. But we're not making the mistakes with the patient. We're making the mistakes with the preceptor, with the person that is teaching us. So I want to make sure that when you learn it, you learn it right and the real people. I can ask you to apply those electrodes on that mannequin. But what's the purpose? What is the purpose? How do you know how an electrocardiogram looks like? You cannot print it out. You cannot run an EKG on a mannequin. Remember, it's a dead. It's a flat line. It's a waste of paper and time. But if you do it in a person, you're going to feel like you did something. And that's exactly what you're going to do with your patients. Because the most important thing is to learn how to apply the electrodes, how to enter the information in the electrocardiograph, and how to print it out, and that is it. And to make sure that if there is any interferences, try to correct it before you print it, and that's it. This is a lot easier than drawing blood, that I can assure you. Okay, last but not least, asystole.
we've heard that before, right?
What is systole?
Face, isn't it?
Hmm?
Like face, like
No, we're talking about systole itself. Remember, we said systolic. What is systolic?
Like the thing.
Contraction.
Oh, okay. Oh,
Contraction.
Like equalization and
Yes.
Okay.
Systole or systole. Systole means contraction.
So
But if I add an A prior,
No.
this means no contraction. So So what happened here? There is no contractions. So if no contractions, which way is going to see on an electrocardiogram? None. It's a flat line. Says okay. Ray, zero. Regularity, not applicable. P waves, no. PR, no, nothing. There is asystole. A, no, without. Without contraction. There is no electrical impulses going there. So this is a flat line. So right here, all pacemakers have failed. So that means that the SA node didn't work, the AP node didn't work, and the Purkinje fibers didn't work. Of course, no waves, no QRS, no T waves. What can cause this? Hypoxia, no oxygen, profound cardiac or other damages, cardiac arrest, a fulminant heart attack. See? Now, if you see this and your patient is laughing and talking, or you see that he's breathing and he's alive, then what is wrong? There's something wrong with you because you didn't place the electrodes correctly, or they're not even attached. So something is going on right here. It's not the patient. It is something with the technical aspect of the procedure. So that's basically what we find right here. This usually comes on an exam. Systole. They ask you, you are running an EKG and you notice a flat line. What is it? Asystole.
Wouldn't that be a trick question? Because if you notice a flat line, it could be and then another beat. It's not.
No, because
But if you
remember,
notice a
don't go
continuous.
beyond what they asking you.
Okay.
It's because we always try to put more things, and that's where we get things wrong. We assume things. Oh, are they asking me this probably after that? No. This is a flat line. This is 6 seconds. In 6 seconds, you should see at least one deviation, but there is nothing here. And when it's written, they said, you have printed an EKG from the patient, and when you look at it, you see a flat line. So, which of the following condition the patient is in? Asystole. That's it. Remember, systole means contraction. A, no contractions. There is no contractions. There is no pumping of the blood. There is no oxygen. All the batteries are down. Let's talk about pacemaker. Remember that I told you that if you are doing an EKG on a patient, when you ask them to remove their clothes from waist up, if you see right here above the nipple, you see a scar and you see a bulging, patient has a pacemaker. Is that understood?
Yes.
And it's on the left side because the heart is on the left side. So those are the things that you have to pay attention. Can you do an EKG on a patient that has pacemaker?
Yes.
Of
Yeah.
course. This pacemaker is replacing the natural pacemaker because it's not functioning properly. So we add a artificial one so that pacemaker can control the rhythm of your heart. Otherwise, you die. So that's basically what it is. Can pace the atrium, the ventricles, both. We have two types of pacemakers. Ventricular pacemaker, atrial pacemaker, or a pacemaker that does both. Let's say that your natural pacemaker is not working. We replace the natural one. Let's say that the Purkinje fibers is not working. We replace that one, the AP node. So either or. Now you don't see the patient. You've been asking a question whether the patient printout presents or not an artificial pacemaker. We're gonna see how you're gonna know, seeing a printout, whether the patient has a pacemaker and what type of pacemaker. A ventricle or an atrial pacemaker. Here, pay attention to this picture. What do you see in this picture?
So one has a P and one doesn't.
Okay, what else do you see?
You can see the QRS, T, a little bit, but no.
Okay, what else do you see?
But they're both regular because
Okay, what else do you see?
it's just a dramatic,
What else besides being dramatic?
bigger, longer.
Look, everything that you see, describe. You mentioned this, you mentioned that, but you didn't mention one thing. You didn't mention these little lines right here.
P.
Oh, you'll see those lines.
See, here you see this, here. What is this line?
The pacemaker.
No, what is it? What is located?
It's the P, right?
It's on the baseline.
Hmm?
It's located on the baseline.
Part of it? What else?
So on the negative side.
Okay. See, this is not easy. First of all, you saw the lines, but you didn't give importance to it. It's very important because this patient has a pacemaker. But there are two types of pacemaker. How do I know which one is the ventricle, which one is the atrial pacemaker?
Because
Mm,
one of them has one line and one of them has two.
correct. So we're gonna see what's going on here. If you look right here, what is this?
That's the QRS.
The QRS. So we have one line before the QRS. And what does the QRS represent for an EKG? Correct. What type of pacemaker is that? Ventricular pacemaker. Aha. I like when my students they feel like, wow, I accomplished something, right? I understand. Because that's the way that you're supposed to teach. You're not going to become a doctor. If you were becoming a doctor, we will spend 3 years in classroom. Is that understood? But you're only going to have 3 weeks. Oh, 3 weeks, by the way, it's 3 weeks. So now, here, what do we see?
It's monitoring both because it has a one before the P and then
Before the P, you see, when you understand one, you see the other
And
one.
that's the atrium one.
This right here is the ventricular. Ventricular, ventricular, ventricular. But here we have before the atrium. So this is the atrial pacemaker, ventricular. So we have both. On the image on the bottom, we have both. We have atrial and ventricular pacemaker or pacing. Here we only have the ventricular pacing. Now, it can be only one before the atria. That means that only the atria have problems, not the atria and the ventricles. Is that understood?
Yes.
Here is the ventricle that have a problem. So we put a pace there. So you're gonna be seeing one of these EKGs, one of these slides, one of the strips, and they're gonna ask you, okay, what type of what do you see here, or what type of pacing you encounter in this EKG? So remember, that's what I ask you. Look at it. See all the things that we haven't seen in other EKGs, because these lines, you cannot ignore them. They are not there for decoration. So you look at it and says, oh, listen, something is standing out over there. And that was before in many of the pictures. So this is how we do it. Pacing, how do you know?
Because it'll have the line before the QR.
The QR.
Okay, for the answer in the question of the exam, he's going to say, because the pacing begins before the ventricles. Because the pacing is located before the atria. That's atrial pacing. If it is dual, it's because the pacing starts before the atria, before the ventricles. That's dual. Two of them.
Can you repeat that again? But because of pacing?
Begins, see, the pacing, look at here first. The pacing begins before the P. The pacing begins before the QR. So that's how you know. Or, remember, they can use, because the pacing is located before the atria contraction and before the ventricle contraction. So you can find two definitions for